Every day, the modern battlefield fills with machines, thousands of drones, hundreds of sensors, more signals than any chain of command was ever built to hold. Somewhere in that noise is the difference between a target and a friend, and minutes you don't have to decide. This is the system built to make sense of it. Not in a defense lab, but by volunteers in 2015, coders and pilots improvising under fire. They called it a kind of Google for the military. One login, one map, the whole war in a browser. A decade on, it's combat proven at a scale no Western program has matched. Underneath is a single data lake. Satellite imagery, radar, signals intelligence, even reports from civilians on their phones, fused into one living picture. It's not one tool, but many working as one. Live drone feeds pour in by the hundreds, aggregated on a single wall. A pilot watching a feed can point straight at a target and designate it, and those coordinates drop instantly onto the shared map, seen by everyone who needs them. Every confirmed strike adds to a running score, the fight gamified, rewarding the crews who feed the system best. AI filters the noise, so humans spend their seconds on what matters. Sensor to shooter collapses from hours to minutes. The instant a target is designated, it becomes a symbol, and every object on that map speaks one language. A blue rectangle is a friend, a red diamond, a threat, a yellow shape, still unknown. The frame opens at the bottom when the threat is in the air. Frame, color, icon, a vector for where it's heading. One symbol tells a soldier in one nation exactly what an ally in another already sees. One picture, no translation. At the edge, the sensors stack into a wall. Radar, radio, sound, layered 15 to 25 kilometers deep. If a drone signal doesn't answer as a friend, the system flags it hostile, and the response moves before a human could have called it. It works because it never stops correcting itself. Every loss feeding the next decision, every point sharpening the next strike. The West is still catching up, and the opening is quiet but enormous. Persistent, wide-area sensing, drawn from infrastructure already standing in the ground, turning the network itself into another set of eyes.